Alright, today we're going to be doing the German tank simulation. This is an introduction into Chapter 7, and so the activity goes back and is a historical connection back to World War II, where the Allied forces were trying to decide whether or not to invade Germany, and a lot of that decision depended on how many tanks Germany had, and so they needed to try to figure that out. And basically what they did was they sent spy planes over Germany to try to guess and count the number of tanks that Germany had. And when the spy planes got the data back, the Allied forces decided, that's too many tanks. There's no way they can be making that many tanks. So they came back and they said, okay, we need to have some statisticians work on this to come up with an estimate for the number of tanks that Germany has, because that just can't be right based off of the intelligence data that the spy planes were giving them. So they hired these statisticians to come into an office in New York. And the only thing they had was they had a collection of serial numbers off of parts that the Allied forces had collected off of German tanks that had been taken. So they captured the tank, they took parts off the tank, they took the serial number. So they had a series of serial numbers off of tanks, assuming that Germany numbered their serial numbers in sequential order. So the very first part was 0001, and the second part was 0002. Third part was 0003, so on and so forth, that they numbered them in a sequential order starting at 1. The statisticians came up with an estimate to try to predict how many tanks Germany actually had. The interesting part was that the number of tanks that the statisticians estimated was significantly less than what the spy planes were predicting, and so based off of that, the Allied forces decided that they were going to go ahead and risk the invasion of Germany based off of the statisticians' best estimates. And so, lo and behold, they invaded the beaches of Normandy, D-Day. You know the history. They invaded the beaches. You see all the pictures, everything like that. They were successful. So based off the math that the statisticians had put together, the Allied forces were successful and they won the war. After the war, they went into occupied Germany, and they were actually looking at the number of tanks that Germany had, and sure enough, the statisticians were actually really, really, really close. What Germany was doing is they knew that the spy planes were flying over, so after the spy planes would fly over, they'd bring all the tanks back into the factories, and instead of making new tanks, they would just take the tanks that they had made, and they would repaint them and put new serial numbers on the outside of them, and then they'd put them back outside before the next spy plane would fly over. And so when the next time the spy plane flew over, it looked like they had created a whole new lot full of different tanks. They were just the same tanks that were repainted. So they were tricking us. So based off of the mathematicians, you can say the statisticians helped win World War II for the Allied forces. So now you guys get to act like those mathematicians in Manhattan, in New York City. So each group is going to have a packet. And inside of this packet, there are going to be little numbered tags. And the little numbered tags represent the serial numbers for the German tanks. So they are in sequential order. They do start at 0, they do start at 001, and they go all the way up to, that's what you guys have to try to guess or figure out, is how high they go. In essence, trying to guess how many tanks Germany had. So you cannot pick all of the tags out, though. Just like the mathematicians in New York, they only had a select few serial numbers off of tanks that had been captured to work with. So you guys are going to pick 7 of these little green tags or yellow tags, depending on what envelope you have, and that's the 7 serial numbers that you guys get to work with to try to develop or create an estimate for the maximum number of tanks, maximum number of tags in your envelope. Okay, your paper that you're going to get to be working on looks a little bit like this. And so, as you can see on here, the first thing that you're going to do is you're going to draw 7 tags out of your envelope, and you're going to put those 7 numbers on this question number 1. Question number 2, then, you're going to find the mean, standard deviation, the minimum quartile 1, the median quartile 3, and the maximum of those 7 tags that you drew. So question 2 shouldn't take you very long. You're just going to put those 7 numbers into list 1 in your calculator, 1 var stats with list 1, and come up with the mean, standard deviation, minimum, quartile 1, median, quartile 3, and maximum for those 7 tags. Do that now. I'll pause the video, give you guys just a couple of minutes to do that. Okay, so by now you should have your 7 number tags listed on question 1, the mean, standard deviation, minimum, quartile 1, median, quartile 3, and maximum for your one sample of 7 tags. So you've drawn 7 tags, you've calculated all these relevant statistics. Now, this is where you have to do a little bit of creative thinking or imaginative thinking. The statisticians in New York had all the statistical knowledge that you guys have and used basic statistical knowledge, nothing complex, that you guys all can easily come up with for their estimates. Your job is to try to create some sort of formula or equation to try to estimate the maximum number of tags in your envelope based off of those 7 that you've drawn. For example, you could say, I'm going to take whatever the maximum is from my sample, and I'm going to multiply it by 2, and that's how many total tanks they had. So I drew in my envelope, I got a maximum of 200, so that means the maximum number of tags in the envelope should be 400. By the way, that's not a very good method, but I wanted to give you an idea of what you are doing on this step right here. You're creating a formula using the minimum, using the mean, using the median, using the standard deviation. Doesn't matter what you use, you get to create a formula to try to estimate the total number of tags that are in the envelope. The formulas are very simple. We've done a lot of different things. These data follow a normal distribution if you wanted to try to do something based off of that. The data, there's a lot of different options you have to create a formula based off of the things that you know that we have done in this class already to try to create a formula to estimate the maximum number of tags in the envelope or the maximum number of tanks that Germany was creating. So this might take a little bit of time for you guys to kind of think about and talk through it and figure out. If you want to talk to your people around you, that's fine as well. Please don't use the same formula as somebody else. I want you guys to all have unique formulas so that we have a little bit of variety with this. So if you talk to somebody, you can use a variation of their formula, but don't use the exact same formula, otherwise it's not beneficial. So I want you guys to all create unique formulas to try to estimate the number of the maximum number of tags in the tank. I can't talk right now. The maximum number of tags in the envelope, or simulating the maximum number of tanks that Germany was creating each month. So I'll give you guys some time to do this. I'm going to pause the video, and then we'll pick back up here in just a little bit when you're ready. Okay, so by now you should have a formula. You should have an estimate based off of your sample of 7 tags that you drew. You should have an estimate for the maximum number of tanks that Germany was creating a month. For example, if you go back to my example that I used a minute ago, if my maximum was 200, my formula is going to be 2 times the maximum, and for this sample my estimate would be 400. You should have all of that right here on number 3. You don't necessarily need to go write it on the board. We'll look at that Monday, maybe when we pick this back up on Monday. So you should have this number 3 done completely with your sample, your formula, your estimate for the maximum number of tags in the envelope. Now what's going to happen is you're going to recreate this process. You're going to do a whole bunch of samples in a row now, and using each sample and the formula you create on number 3, you're going to come up with another estimate. So, example, I'm going to draw 7 more tags out of my envelope. I'm going to use my formula to create my new estimate. So for this particular sample, my maximum number that I got was 171. So my formula that I use, 171 times 2. My estimate for that sample would be 342. Okay, so I'm going to write that down here. I'm going to write down my maximum was 171. I'm going to write that down on this line. And then over here, I'm going to write 242. I'm going to put all of the tags back into the envelope, shake it up a little bit, and I'm going to do it again for values used number 2. So I'm going to draw 7 more tags out of here, and I'm going to find the maximum in there. And in this one, the maximum was 233. So I'm going to write 233 on this line, and for my formula, it would be 233 times 2, or 466. By the way, don't use my formula. It's an intentionally bad formula, but I just want to give you an idea of what's happening. So you're going to take and you're going to repeat this process 15 times. You're going to go and re-put the tags back in there, draw 7 more. Find your estimate. Put the tags back in, draw 7 more, find your new estimate. So when it's all said and done, you should have 16 total guesses for the estimate for the maximum number of tanks. There's going to be variability to it. We know there's going to be variability. They should not have the same number. They should all be reasonably close if your formula is a very good formula, because again, we want to try to reduce the variability as much as we can, but it's not going to necessarily be the same value. Then on number 5, you're going to draw a dot plot. And on this dot plot, you're going to sketch your 16 estimates for your method, and you're going to describe the shape, center, and spread of your distribution. So you're going to have a dot plot right here. You're going to have all of those 16 samples plotted on your dot plot, and then you're going to describe the shape, center, and spread. Next, so I'm going to pause it. I'll stop for a second. I'm going to pause, let you guys go do that. Do your 15 more samples, create your dot plot, draw your shape, or describe your shape, center, and spread, and then we'll go to number 6. So I'm going to pause here and let you guys do number 4 and 5. It's going to take you guys some time here, probably 20 minutes or so to do all of this, because you have to put each one in your one variable stats and find your relevant data for whatever it is you're working with there, for whatever your formula was, and then find your 15 samples, plot it, and then we're going to go on to number 6. So I'm pausing it now, give you guys time to do your 15 samples and draw your dot plot. All right, and welcome back. Hopefully now you have your dot plots done. You should have 16 dots on every group's dot plot. You don't necessarily have to put them up on the board or anything like that, but I do want you guys to share your formula and share your dot plots with the whole class. Kind of just show them real quickly. You guys may want to get around and group up or something like that, but talk about it, and then I want you to discuss which one did the best job in terms of what we know about statistics of estimating the total number of tanks. Remember, things we're looking for is low variability and somewhat of a nice shape or somewhat representative shape. Could be normal, could be other types of shapes, to try to do the best job of guessing for the maximum number of tanks. I will give you this hint. The formula that the Germans used did not come from a normal distribution, and so it's okay, and we'll talk about more of that a little bit more on Monday. But I want you guys to have a quick 5-minute discussion here about which method from your class did the best job of estimating the number of tanks, which ones were highly biased, which ones were highly variable, because again, we want low bias, low variability. Now the bias part of it's going to be a little bit hard to discuss because you don't know the total number of tanks unless I tell you. The total number of tanks that Germany was creating a month is basically the total number of tags in the envelope is 340. So the maximum, your graphs should be centered fairly close to 340, because that is the maximum number of tags in each envelope. So there you go. Now you have it. You know the maximum. Please don't share that with other hours, because that'll ruin the surprise or ruin the activity. So do not share that value with any other hours so that they can go through this process and come up with good estimates and have the joy and the experience that we're creating here. So if you want a little bit more information about this problem, there is a handout here that is on the desk that the sub can give you here. It looks a little bit like this. Let me pull it up here. And it kind of goes through and explains this problem and gives you the formula that they used and how well Germany actually did, or how well the intelligence community did, how well the statisticians did in terms of after the war. And so the process for this is explained on there as well. So if you want that handout, the sub has a couple of copies of that handout. You're welcome to take them. Otherwise, that's good for today. If we have time left in class, the rest of the time you guys can use to start looking at 7-1 notes and stuff. Please make sure that you bring your laptops again tomorrow to class. charged, ready to go, because tomorrow we'll have a video for Section 7.1, introducing 7.1 and applying these things today.